Welcome to another Unreal Engine 4 tutorial, and today we are going to talk about line tracing, sphere tracing, box tracing. We're going to create our own custom trace channels, and I'm going to show you how we can actually use these things in a game, because there's a lot of cool stuff that we can do with this. It simply will help us to detect and find a lot of different actors and all kinds of different things. We can interact with things and all kinds of stuff using these traces. So the first thing that I want to mention real quick is often, well, at least with the default objects, they will not have proper collisions set up. So this might come into play when we are trying to detect these things with these traces. So some issues might happen, that some things might get ignored because of the fact that they have bad collisions perhaps. So make sure you go to my channel and have a look at the beginner series playlist, and I have a video over there called Collisions and Physics, where I go over how to create custom collisions on your own, because it's often, if the object is very complicated, it's often better to create your own custom collisions rather than using the ones that Unreal generates by default. So but let's assume that you already know that the collisions are fine. In default objects usually they will be, and for the most part things will work. It's just that sometimes it's going to be a little bit awkward if you don't have this proper collision setup. But let's start off with something very simple, and let's start off with line trace by channel. So I'm going to go to my third-person character real quick, and over here what we are going to do is simply look for a node called line trace by channel. So what this thing does is essentially it shoots a line from the start position till the end position, and you just simply need to provide some kind of coordinates inside of the world. Now let's go ahead and let's say that we want to do a line trace from 0, 0, 0 up until let's say 500, 500, 500, like so. Now we need to actually run this somehow, so what I'm simply going to do is create ourselves a keyboard one key event, and that's going to be it. That's what we are going to use for now. So now if we click 1 now, it's going to create this line for us, but by default it's invisible, like it should be. During the gameplay there's a lot of tracing happening and those lines are not visible, but while we are developing we can go ahead and enable this line so that we can see what is actually happening. Now to enable this line, go to the draw debug type, and you can select any of these options. So for 1 frame, it means that the line is going to be drawn for just 1 frame, so it's going to be really hard for it for you to spot it. For duration, that means that it's going to be drawn for a specific time, and if you open up this advanced options, you can specify for how long that line will be on your screen. And the last one is persistent, which means that it's simply just going to stay there and it's not going to go away. Usually what I use is for duration. That's the one that I use most commonly. And also there are 2 colors over here. You can see the trace color and the trace hit color. So what that means is basically whenever a trace goes out, it's red by default, and whenever it hits something, it continues its route being green. So let's go ahead and now just with the for duration and setting up the end position, let's try to run this. So if we hit 1, there we go. Here we can see the line trace. So here at this tip of this green line is the 500, 500, 500 coordinates, and that is the 0 position over there. Now we can run this thing from basically anywhere, and this is a really cool thing because we can detect things. So whatever it hits, it's going to tell us what it hits. And to do so, to receive this information, here is the out hit. If we drag from that and we break the result, it returns a lot of information about the object that it has hit, how long it took it, what was the distance to get there, where is the impact point, what is the hit actor that you have hit, what is its physics material, or which component we have hit, maybe if it's an instance, maybe if there's multiple instances, so it's an instance static mesh, for example, it's going to return the index from the hit item. It's going to tell which instance index it is. It also will return the bone names. It's going to show us where the trace started, where the trace ended, so we can output a lot of useful information over here. So let's start off by doing what I usually do first. Is actually I do a if branch check from this return value, because this will tell us whether it has hit something or it hasn't. So obviously true or false, whether it has hit something on true, and false if it hasn't hit anything. Now if it did hit something, let's just go ahead and let's use this handy node called print string, which is going to print out a text on our screen, and we can plug in the hit actor, and it's going to print now out whatever it has hit. Like we saw, it went through the ground, so it probably will hit the floor first. So let's hit 1, and at the top left you can see that it says floor. And now we can go over here, select this, and you can see this is the floor and this is the object that it has hit. Now, we don't necessarily have to run this through our third-person character. We can do this wherever we want to do this. It can happen through anywhere. It can happen in our level blueprint, and it can happen in any other actor. So for that, real quick, let's create ourselves a very basic actor. I'm just going to call this new blueprint, let it be. And what we are going to do is on begin play, or better, let's do this on event tick so that it stays there. It's going to be a little bit easier to spot this. Let's do a line trace by channel. So the start position, I want to shoot the line trace from this specific object's location. So I'm going to get actor location, and this node will return me the location of this actor as long as we leave this target at self. It's going to tell us where this specific actor lives. Well, its coordinates. So we're going to plug that into the start position. And another thing that we need is the end position, and I want to shoot a direct line forward. So I'm going to look for get actor forward vector. And this basically gives me a direction forward. And we need to give this some value. We need to multiply this with some kind of a value to tell how far up ahead we want to do that. So from the return value, we just simply want to multiply this. I'm going to use integer. You can use float as well. I'm going to use integer. And let's say we want to shoot this line 2000 units forward, straight forward. So we're going to use that like so. And for the end position, then we need to go ahead. We need to grab the actor's location. So actor location, and we want to do plus vector. We want to combine this with the forward vector times 2000. And whenever we do that, this one is going to return us the location 2000 units in front of our object. So we can set that at the end position. And now again, I'm going to enable the for duration so that I can actually see the line. So we can compile and save this. And since this is ran on event tick, it's going to get ran constantly. So now we can just bring this actor in, and I'm going to bring it up a little bit so it's not in the ground. We hit play, and there we go. You can see here is the line that is getting drawn. As you can see, it is ignoring me. There's a couple of reasons for that. I'm going to explain those in a second, but as you can see, it starts off red. This is where the actor was placed. Once it hits something, it creates this red square, which tells you, basically informs you that it has a hit point over there. And then it continues on being green because, well, it has hit something. And it goes, like I said, 2000 units forward. So I guess it actually leaves the map in this situation. So now with this, we can actually do a lot of things, because whenever we have hit something, we have all the information that we need to start interacting with some kind of an object. So from the hit actor, we could go ahead and cast to the character, for example, and we could bring out some kind of information from there, or we could use even better like an interface when something happens. But always I prefer to run the if branch check so that it doesn't try to cast unnecessarily, so it only runs it whenever it has hit it. So we don't want to run unnecessary code if it's basically not possible. If we didn't hit the character, we don't want to cast, even try to cast to it. It's just simply pointless. So this is line trace. Let's now, so like I said, it did not interact with us. And that is because if we would have a look at the collision rules, so select your capsule component, scroll down till the collisions, you have the collision preset which says pawn. You can see that the pawn is actually ignored by the visibility trace channel. So this is one of the things that I spoke about in the collisions in physics video. There are a lot of different object types, and you can collide, overlap, or ignore any of these types. So in this situation, if we look at the trace, in the trace channel, we are using the visibility. That's the one that is getting used by default. We are using this in both of our traces. And if that one is getting ignored, for this specific object, in this case our character, if it's ignoring that one, well, that means that it's not going to interact with the character because it's using a trace that is getting ignored. So you can change that really easily by going to the collision preset and setting this to custom. But always when you go to custom, make sure that you remember which one it is. You can always go back to the default by clicking this one, because if you're going to set this to no collision, you just messed up all of your collisions. And now if you go to custom, it's again going to be a bad thing because you're going to have no collision. All kinds of things are going to be bad because, for example, as you can see, boom, we just fell through the map. That is because our character now is ignoring a lot of things. It has no collision whatsoever. So always just reset this back to default and then go to the custom, because now you will have the same exact collision rules as the pawn class did. But now you can modify this one specific trace. So we are going to block the visibility trace on this one. So now you will see that if I walk inside of here, as you can see, it did detect my character and it tells me, hey, we just collided with the character, and it shows up that square over there. So that's how you basically detect this. And you can actually set up your own trace channels. That can be multiple trace channels. If you will follow my upcoming building series, you will see me create multiple different trace channels. That is so that I can interact with specific objects with a specific trace, but maybe with a different trace I would interact with different objects, because I don't always want to interact with the same objects. So you can go to the settings, and under the project settings, under the collisions tab, we have the trace channels. So we can add ourselves a new channel. So let's create a new one and let's call this test trace. By default, I usually block it. This will set like the default settings for every single object. Everybody will be blocking this trace. If you know that the majority of the objects should be ignoring this, but just one specific thing needs to block it, then maybe by default go ahead and set it to ignore and then block it where it needs to be blocked. But usually I just leave it at block and then go from there. So we have this trace now added. We have the test trace, and instantly if we recompile the blueprint, I think we need to recompile, maybe not, but under the traces in our line trace, we have this trace test. So now we can use that one instead. So let's go ahead, let's use that. And let me bring back the capsule rules back to default. And you will see that now in this section where we have these traces, we have the visibility now ignored because that's the default value. And we also now have this test trace, which is getting blocked by default. So now, again, we can walk in and it is going to detect our character because now it is using that test trace. You can see this one. So we have the test trace. Now, there are even more possibilities with this. So this is just the default line trace by channel. It just interacts with the first object that it hits. There are a lot of different types of these things as well. For example, we have a multi-line trace by channel. And essentially this is the same thing. This is pretty much the same thing. So let's go ahead, I'm gonna hold Control and reconnect the start to the start and end to the end. And I'm going to actually delete this one now. And I'm gonna bring this one in. These two are very, very similar. The difference between these two is that the regular line trace by channel just detects the first object that it hits. Multi-line trace channel returns all the objects that it have hit along the way. As you remember, the line hit the first object and turned from green to red, and it ignores everything else that comes after that. With multi-line trace, it is going to detect and return information about all of those objects in that line. So let's use the test trace for this one. Again, I'm gonna draw this for duration. And here now we have different out hit. So I'm going to again connect the branch to see if we actually hit something, because if we never hit anything, none of this really matters. We can just skip the rest of the code. But now we have a bunch of results from the hits. So here we can do a loop for each, and it's going to go through all of those objects that it just hit, and it's going to return us our hit result. So it's very similar to what we just saw. The difference is that, well, now we have multiple instances of them. So we can again go ahead and print out to see what it is that we actually have hit. And we can go ahead and print the hit actor, and it's going to print the hit actor's display name. So now again, let's hit play. But as you can see over here, it basically did exactly the same thing. It did not detect all the other objects like I said it would. It only detected the first object. Now the reason for that is that there is a little bit of a difference between a regular trace and multi-trace. Now for the regular trace, we need to make sure that we are blocking. If we are overlapping, it goes through it. It works exactly the same as the ignore would. But for the multi-trace, if we want to make sure that we can detect multiple things, we need to make sure that it is overlapping. So in this case, this object right here is blocking it. So it hits it and it doesn't go forward. We got to make sure that it is overlapping it so that it can interact with the next object. So to do so, let's select the cube, go to the collisions, collision preset. Let's set this to custom and let's go ahead and let's overlap. And let me just duplicate this and make another one. And now let's hit play. And now you can see that here is one hit point, there is another hit point, there is another hit point, and it goes on, as you can see, like this. Now, this object right here is blocking it. It is not overlapping it. So as you can see, from over here, from the green line, it's no longer going to detect anything because this object right here just blocked it and it did not allow it to keep tracing forward. So yeah, make sure to set the collision rule for that specific trace channel to overlap if you want it to detect multiple objects and block it whenever it should stop detecting things. But usually, well, you will set up the somewhat correct distances. That's a good practice to set up the proper distance. So in this case, it should not be 2000, maybe 1000 at max. So it doesn't go that far. It doesn't have to go that far if we simply want to block it so close to the starting position. So that's basically how it works. There are multiple different ways how you could do this, you could use this, because now you have all the parameters, you have the distances, you have the names, components, actors, indexes, bones, all that good stuff. So you can do a lot with this now. So these are the line traces. There are also box traces and sphere traces. So let's talk about box trace real quick. So we have the box trace by channel, and remember, all of these have two variants. So all of them we have the line trace, box trace, and sphere trace, and also we have the multi-line, multi-box, and multi-sphere traces. So all of them have both of these options. So I'm gonna delete this one for now, well, for good actually, and we're gonna add the box trace, and I'm going to show you how that works. So we're going to use the regular one. We're not going to use the multi one, but same rules apply with the overlap and all that stuff. So keep that in mind. All of them really work the same. It's just the difference is what kind of a shape gets shot out from here. So let's go ahead and let's again create something very similar. So from the position of the actor 2000 units forward, we're going to shoot this box. So that's going to be the end position, this one, and the start position is going to be the actor's location. Now we need to provide some kind of a size, because now if we again test trace for duration, you will see that now if we hit play, it's just a line. There's nothing to it because the size of it has been set to 0. So it's again going to interact with the first object that is getting blocked. Right now we are overlapping. Like I said, regular traces on overlap are just simply going to go through it, and it's going to find the first object that is blocking that trace channel. Now if the half size is set at 0 instead of a box, we basically get a line. So let's set up the sizes to 40Y and 40Z. I'm going to leave X at 0 because in this specific example, when we shoot it forward, the X doesn't really matter because it's always the forward way is the X axis. So if we hit play now, you will see that now we have a way larger surface area. As you can see, now we are actually creating a box that is getting shot forward, like so. And of course, if we walk into it, we are getting detected because, well, the character is getting blocked by this trace. Now, also, usually what I do with this, I don't usually do this to shoot, to detect things that are forward, like we did with line trace. Instead, I have a little bit of a different application for this. Usually, I grab some kind of an object and I test to see what's around it. Basically, I'm trying to detect things around that object. So let's go ahead and let's try to do that. So what I'm going to do is first I'm going to add us a little bit of a component. So I'm going to add a box collision component just so that I can specify a size. So this thing automatically is going to specify me that size. So let's say we set this to like 100 by 100 by 100 in the box extent. So we have this box of this size. So you can see that in the world as well. Here is that box. And back in the event graph, now we can go ahead, we can grab that box and we can get its sizes and we can provide that information over here. So what we can do is from the box get component bounds, and we can use the origin point for the start and for the end position, and then we can use the box extent as the half size. And now what this will do is it's going to create a trace exactly the same size as this box. So if we hit play, there we go. We have a trace exactly of that size. So we can try to see if something is inside of this specific area, as you can see. And also, of course, if you go ahead and in here, instead of changing the settings in here in the actor, instead of changing the box extent over there, you can also always go ahead and do this in the world as well. And as you can see, it still grabs the size of the box, whatever it is in the game world, and it is creating a trace from that. So this is a cool feature as well, so we can detect things inside of this specific area. Now there is one more trace. The last one is the sphere trace. I already have set it up actually. Basically what I did is a very basic setup. What I have over here is the camera, so my fellow camera. I'm getting its world location and its forward vector again. And then for the start position, what I did was I took a location 300 units in front of my camera, and I took a end position 2000 units in front of my camera. Now the reason why I added these units is because sometimes if you have some kind of attachments added to your character, these traces will detect those things, and then, well, we don't necessarily want to detect those because usually you will keep references about the things that are attached to your character, so you will simply don't really care about detecting them with traces. So what I did was simply I had a look at the camera booms target arm length. So that's basically how far away the camera is from the character, as you can see. So that's 300 units. And basically then what that means is that I grab this specific location, so the middle point, and I do a trace from over there and I shoot it forward, so that I would ignore maybe the backpack or some kind of clothing that I might have or whatever that could be attached to my character. Now the difference with these two, so for the box we have the half size, but for the sphere we have the radius. So we can set this to something like 10, and now you will see that whenever I hit 1, it creates me a sphere that is getting shot forward, like so. And this is really useful. In my tutorials I usually use the line trace, but you can also always use the sphere trace, which is kind of a little bit even better because this gives you again a bigger surface area to detect things in. As you can see, you specify a bigger radius and the trace is a lot bigger, so it could be a lot easier maybe to interact with some of the objects, as you can see. But yeah, in the big picture, that's pretty much it about the traces. They are very useful, and if you are going to keep following my tutorials, I'm going to have a build system series soon, which is going to use a lot of different trace channels in a lot of different methods. We're going to calculate distances, we're going to find locations where to build, and all that good stuff. So yeah, that's going to be it for today's video. If you have any questions, leave them down in the comment section down below. And yeah, thank you for watching, and see you in the next one.